All right, here we are. Looking at these two equations. Do these look like they have one solution, infinitely many solutions, or no solution? No solution because they do not intersect. When you have solutions to equations, that's where their graphs will intersect. This one has a slope of 1/3. This one has a slope of 1/3. Since they both have the same slope, they are parallel to each other. Since they're parallel to each other, they will not intersect, so there is no solution. It says solve this equation graphically. So you graph them out. Okay? So when we graph these out, we get an equation that looks like this. Okay? We get something on our graphing calculator that looks like this. You all have graphing calculators, you can graph it. Okay? So when we graph it, we see that. So then you have to trace to where they intersect, to the 2 points where they intersect. Okay? I'm thinking that they do not intersect at 0, 0. I think because if I try 0 and 0 in here, those do not match up. Okay? So you just have to solve and figure out where, or use the trace button or your intersect button to figure out where they intersect. Okay? So, sorry, I need to show you one other thing on this one. Okay? On this one, can you just enter it into your graphing calculator this way? No. So what you have to do is get y alone. So 2y equals x plus 1. So y equals, parentheses, x plus 1 divided by 2. So that's the way you'll enter these in on your graphing calculator. And like I said, use the second trace button, intersect, to find the 2 points where they intersect. Okay? When you see this, okay, again, graphing calculator, get y alone and figure out where they intersect. Or what you can use is there's a program that's called Desmos. Okay, so let me go to Desmos once. Desmos, graphing calculator from Desmos. And there it is. Now, in Desmos, you do not have to get x and y alone. So you can type it in the way it is there. 2x plus 5 equals 1. 2x plus 5 y equals y equals 1. And then to add a second equation, you just click down here. And it's 7x minus 4y equals negative 18. 7x minus 4y equals negative 18. And look, you can find exactly where they cross right away at negative 2, 1. Okay? So that might be a little easier than your graphing calculator for some of these if you use Desmos. There is one solution because it's where they cross. And I guess they didn't ask where they crossed. Okay? So you can do a couple of these on Desmos. Now, this one. A rectangle has an area of 16 inches squared and a perimeter of 20 inches. Find the dimensions of the rectangle. Wow, this is going goofy today. There we are again. So I would draw a rectangle. Make my width x, my height y. If it has an area of 16, what do you do with the width and the height? Multiply them, right? To get 16. For the perimeter, it's 2x plus 2y equals 20. I got to solve those simultaneously. Let's see what Desmos does to them. So I'll go into Desmos. I'll say x times y equals 16. And then 2x plus 2y equals 20. Now, you have a line here that crosses this twice. Right here, it'll be at 8, 2, and right here, it'll be at 2, 8. Does it make a difference, 8, 2, 2, 8? One length is 8, the other one's 2. So the dimensions of the rectangle are the smaller dimension in the first box, so it's 2 by 8, and yeah, I don't know, the dimensions of the rectangle are that by that. The dimensions of the rectangle are so many inches by inches. That's weird that it comes up twice. I don't know why that did that. Okay. A boat's crew rowed 12 miles downstream with the current in 2 hours. Okay. So you have their speed of rowing plus the current, and then when they come back upstream, it's their rowing minus the current. Okay? So if they rowed for 2 hours, their rate times time equals their distance. Okay? Rate times time equals distance. So against the current, it took 3 hours. So their distance that they rowed is 2r plus 2c, and their distance they rowed this time is 3r minus 3c. Okay? What do you think about those two distances, though? They are the same. The distance upstream and downstream would be the same. So what do you do with these two? Since they're both equal to the distance, you set them equal to each other. Okay, so subtract r from each side. And then add 3c to each side. So 2r equals 5c. Divide by 2. Oh, the distance is 12. Dang it. There we go. So instead of setting them equal to each other, solve them simultaneously. Sorry about that. So I would multiply the top row by 3, bottom row by 2. So 6r plus 6c equals 36. And 6r minus 6c equals 24. So 12r equals 60. So the rate they rowed was 5. If you put a 5 in the top equation, you get 30. So c must be 2. Does that make sense? 30. Oh, no. C must be 1. So the velocity in still water is 5 miles an hour, and the current is 1 mile per hour. Okay. You do the same for the plane. Rate times time equals distance. Their rate They're flying against a headwind, so the speed of the plane minus the wind for 3 hours, they go 1,200 miles. The return trip, the plane plus the wind only took 2 hours for the 1,200. So P plus or P minus W times 3 equals 1,200. P plus W times 3, 2, equals 1,200. So 3P minus 3W equals 1,200. Actually, what I should do, what would be easier is divide both sides by 3 here, divide both sides by 2 here. So P minus W equals 400, and P plus W equals 600. So if you do that, then 2P equals 1,000. The plane speed is 500 miles per hour. And then to find the wind speed, just plug that in. So if this is 500, the wind must be 100. Ooh, that's a strong wind up there. All right. So